Today we're working on Module 4, Lesson 34, the last, the final, the very no more one of Module 4. We're finally done with Module 4. Today we're going to be looking at inequalities and writing them and graphing them. Some of this may look familiar because it did show up on your cumulative reviews, and we did introduce this to get ready for the state tests. But today we're just going to have some more practice with it and develop it a little bit more, okay? So some of this probably look a little familiar. All right. So Caleb has at least $5. Okay, here in my pockets, I've got money. So let's figure out. He has at least $5. So if he has at least $5 in his pocket, could it be $5? At least 5. So it could be 5. So could it be $6? No. Because it's at least 5. 5 is the least that it could be. 5 is the smallest that it could be. So if it's at least 5, could it be 6? Could it be 7? Could it be 8? Let's stop and think about it. It's at least 5. So 5 is the smallest it could be. I've got at least $5. So if it's at least 5, could it be 6? Could be 6. It could be 7. It could be $5 and a penny. Could it be $4? No, because it's at least 5. So it's 5 or more. So what Caleb has is greater than or equal to $5. Because it's at least 5. 5 is the least it could be. 5 is the smallest it could be. But it could be 5 also. Less than or equal to C. But now we want to graph it. So if we were going to graph 5, because it could be $5. So we put the dot on the number line. You did that since kindergarten. That's 5. Okay? But now it could be everything bigger than 5. So we're going to extend our arrow that way to show what Caleb has is $5 or more. Okay? Now, Tarek has more than $5. So Tarek has more than $5. Could he have $5? No, whatever he has is more than 5. So whatever he has is greater than 5. Now, here's where it's going to get a little different. It cannot be 5. So how am I going to put this on my number line? I have to be careful. I can't start at 6 because it could be 550, 525. What am I going to do? Exactly, an open circle and then the arrow. So it means greater than 5, but not including 5. Okay? So when there is this equal sign, we use the closed circle. When there's no equal sign, we use an open circle. So let's write our expression for, I'm sorry, not our expression, our inequality. Let's write our inequality for Vanessa. Vanessa has at most $5. So could she have $5? Yeah, she could have $5 because that's the most that it is. But it's also everything, right, so less than or equal to 5. So I can fill in my 5 and then it's everything less than that. Lee Chen has less than $5. I'm going to use an X because I don't want to use an L because then that can get confusing. It could look like a 1. So I'm just going to use an X. He has less than $5. Could it equal $5? No. It's less than 5. So I'm going to use an open circle because it's not equal to 5. Any questions on 1 through 1? A through D. Any questions? Okay. Yes. He has at least 5. So that means he has 5 or more. So he's got greater than 5. It doesn't say 5. Oh, yeah, 5 is the least or more. 5 or more. It's the smallest it could be. All right, Kelly works for a quick oil change. If customers have to wait longer than 20 minutes for the oil change, the company does not charge. That's very good policy, Kelly. I will keep coming back to your store. The fastest, oh, Kelly, I'm impressed. The fastest oil change that you have ever done took 6 minutes. Show the possible customer wait times in which the company charges the customer. So it won't be more than 20, but it won't be less than 6. So your oil change is going to take between, how long? So how long? Between what? Between what?
6.
Right. You're going to wait anywhere between 6 minutes or 20 minutes. So we're looking at between 6 and 20 minutes. So your exact time we'll put as an X. So X, you're going to wait more than 6 minutes. But you're also going to wait less than 20 minutes. Now, should one of those also have an equal sign? It says if customers have to wait longer than 20. So can it equal 20? You have to wait longer than 20. So can you wait 20? Yes. The fastest she ever did it was 6 minutes. So could it be 6 minutes? Yes. So we can write our inequality that way. And now let's draw it. X is everything greater than 6, but less than 20. So greater than 6, but less than 20. Okay. Yes. Because she can do it in 6 minutes. The fastest she ever did it was 6 minutes. All right, Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work at least 6 hours to save enough money, but he must work less than 16 hours this week. Write an inequality to represent the situation, and then graph the solution. So first, let's write the inequality. So how much does he have to work? Between what and what? Between what and what is he going to work?
6 hours and 16 hours.
All right, so he's going to work somewhere between 6 and 16. So it's going to be greater than 6 and less than 16. But do we need equal signs somewhere? It says he has to work at least 6 hours. So will it be equal to 6 hours? Yes. But it says less than 16 hours. Can he work 16 hours? No. So that's our inequality. Now let's graph it. Since it can equal 6, we're going to use a closed circle. So he's going to work between 6 and less than 16. Open circle because it's not equal to 16. All right, let's still try 1 or 2 together, and then you could try some on your own. Blatant is at most 2 meters above sea level. Go ahead, write your inequality and graph it. Blatant is at most. All right, let's go over these. All right, so blatant is at most 2 meters above. So if that's the most, he has to be below it, okay? Or if you want to use B for blatant, or you could use X, that's up to you, okay? X is usually what you're going to see like the general variable. So he's less than or equal to 2 meters. So it's closed and to the left. Edith must read. So she's going to read, or you could use E for Edith. Must read for a minimum of 20 minutes. So 20 is the least that she has to read. So she has to read more or equal to 20 minutes. So she has to read 20 minutes or more. Number 3, Travis milks cows each morning. He has never gotten less than 3, but he always gets less than 9. So what he gets is between 3 and 9 when he milks his cow. So he's never gotten less than 3. He's never gotten less than 3, but that means he's gotten 3. However, he always gets less than 9. So that's what your inequality should look like. 3 is a closed, 9 is an open, and it's how much milk he gets could be anywhere in between. Now, number 4 gets a little confusing because there are distractors in it. Rita can make 8 cakes for a bakery each day. So far, she has orders for more than, there's your key word, more than 32 cakes. Right now, Rita needs more than 4 days to make all 32 cakes. So there's keywords again, more than 4 days. So what are we trying to plot? What does she need? That one's a little misleading because you don't know which piece of information. But if you look at your number line, you can see what they're asking you. So she needs more than 4 days. Okay, because to make 8 a day, if she has more than 32, you can figure out we're looking at how many days does she need. So she has more than 32 cakes, and she could only do 8 a day. 32 divided by 8 is 4. So she needs more than 4 days. Okay, so X is their number of days, and she needs more than 4 days to finish. Because if she does 8 a day to get to 32. And now, she's got to get them all done in 7 days or less. So she needs more than 4 days, but she has to get them done in 7 days or less. So this is what your graph is going to look like.
Number 4, wasn't the 4 being open?
Yes, I'm sorry. She needs more than 4 days. All right, let's take this to the next step. I'm going to try something a little different now. But first, were there any questions on 1 through 5 before we move on? Nothing? All right, Casey has been mowing lawns to save up money for a concert. He earns $15 per hour. What do we know per means? What operation does per mean? No. Multiplication. So $15 per hour. So you would multiply $15 times the number of hours. So per means multiplication. He needs at least 90. So we need $90 or more to go to the concert. So how many hours should he mow? Well, do we know what the hours are? We don't know what the hours are, but I know that if he gets $15 per hour, he needs at least $90. Okay, $90 is the least that he needs, or equal to 90. But I need to know how many hours. Do I still know how many hours? How can I find out what the H is equal to? Well, both sides. I'm going to do the inverse operation and divide both sides by 15. That leaves me with h on the left. And what am I left with on the right? With 90 divided by 15. So he has to mow for 6 or more hours. So 6 or more hours times $15 an hour will equal his $90. Rachel's still making her cakes. 8 a day, and she has orders for more than 32 cakes. How many days will it take her to complete the orders? So if it's 8 cakes per day, and she needs more than 32. So 8 cakes per day, and she needs to make more than 32. But I still can't graph that because those are 8 days. I want to know how many per day. I need to know how many days. So how am I going to find out what the days are?
We have to do 8 days divided by 8.
Yeah.
32 divided by.
Perfect. Good job. So D is greater than 4. So she will need more than 4 days to bake all those cakes. It's an open circle. So she needs more than 4 days. Right? 8 times 4 is 32. She needs more than 32. So she needs more than 4 days. Okay, let's try number 8. Ranger saves $70 per week. He needs to save at least $2,800 to go on a trip to Europe. How many weeks will he need to save? So if it is $70 each week, and he needs to raise at least $2,800. Okay, it can be equal to 2,800. So divide both sides by 70. Sounds like an elephant. What is 2,800 divided by 70? 40. So 40 weeks or more he's going to have to save. A long time. Yes. Where did I get what? Oh, okay. Last one that we're going to do. Ready? Clara has less than $75. She wants to buy 3 pairs of shoes. What price can Clara afford if all the shoes are the same price? So she wants to buy 3 pairs of shoes, but it has to be less than $75. So if all 3 has to be less than 75, what does 1 have to be less than? How am I going to figure that out? I don't want to know about all 3 being less than 75. I want to know about 1.
Well, first you have to divide both sides by 3, and then 1 must be less.
Okay. So X is less than 25. So each pair of shoes has to be less than $25. So $74.99, $24.99, we're good. $25, too much. Any questions on that? All right, that's how you graph and write your inequalities.